Last goal under trigonometry is being able to graph. And remember, the purpose behind all these graphs is to be able to give you a visual to show the same information that you do if you did it by hand, if you did it with a simple expression, some of the things that we've already done in the earlier videos. So sine graph, we've already been through these values, playing around with things. But amplitude, remember, is your wave height. Amplitude always has to do with the letter A, give you an idea how high or how low, period. If you think about how quadrants work with sine and cosine, quadrant 1, everything's positive. Quadrant 2, sine's positive, but cosine's not. Quadrant 3, they're both negative. Quadrant 4, cosine's positive, but sine's not. When do they repeat? They start repeating themselves once you get back to quadrant 1, or after you've gone all the way around the unit circle, 180 degrees, or after you've gone, 360 degrees, or after you've gone all the way around 2 pi radians. So period for cosine and sine, 2 pi divided by b. And you'll notice that b would be the value that you're multiplying your variable by inside this equation. Phase shift and vertical shift. Phase shift has something to do with letter C. The fastest way for me to think about it, if you take that x minus c that's in that equation up there, that x minus c, and set it equal to 0, your graph will recenter it at x equals c. So when we look at phase shifts, we're talking about how to recenter the graph horizontally. Vertical shift, that has to do with the letter D. If D is positive, we're going up. If D is negative, we're going down. All right, so there's your background. Now let's look at sines and cosines. So sine graph, according to this, it looks like both A and B are 1, which means that my amplitude is going to be 1, and the period is going to be 2 pi divided by 1, or 2 pi. So here's 2 pi, pi over 2, 3 pi is over 2 if you count that off. Amplitude said 1, so go up as high as 1, go down as low as negative 1. Now you're making the sine wave. So the sine wave, let's see if we start off with specific values. Let's see, sine of 0 we've already done is 0. Sine of pi over 2 is 1. Sine of pi, we're back at 0. Sine of 3 pi over 2, or 270 degrees, is negative 1. Sine of 2 pi, we're back at 0. Cute little sine wave. Cosine, very, very, very similar graph. I'm hoping that you'll remember. Again, the amplitude is 1. The period is 1. Looks like I'm missing some lines here. So throw a couple marks on there. So here's my graph. Again, we're going as high as 1, as low as negative 1. We're going to put 2 pi here and pi in the middle, and half of that would be pi over 2, and 3 times that would be 3 pi over 2. Again, put your marks on. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine 3 pi over 2 is 0. Cosine of 2 pi, back at 1. Every cosine graph will be some derivation of that shape. So there's your basis. You got your sine graph, you got your cosine graph. You're going to need those to do a lot of things. I think before I move on, I'm going to do the tangent graph, and then we'll make a video to do some reciprocal functions. So tangent graph, well, we've got it. Now here's the tricky thing about tangent. There is no amplitude because it's not really it's not a wave, but amplitude still has something to do with the letter A. It's not going to give us a wave height, not going to give us a max or a min. It's going to give us a specific value that's on the graph. Period. If you think about how tangent works, tangent's positive in quadrant 1 and negative in quadrant 2, and then positive in quadrant 3, and then negative in quadrant 4. So how long does it take to repeat itself? It only takes 2 quadrants, which means we only have to figure out the period. We take pi and divide it by b instead of the 2 pi that we used for sine and cosine a minute ago. It's like I'm missing a tick mark again. Okay, so here's what's going to happen this time. So this one, again, A is 1 and B is 1, but this time the period is going to be pi divided by that 1. So this time we're going to be a little different, but I want to label it so it's similar to what you just saw. 2 pi, pi, pi over 2, 3 pi over 2. But remember this time, this graph is going to take place between 0 and pi. The entire graph, one period is going to take place between there and there. So when we go to create this graph, I'm going to add in a couple more tick marks. I'm going to add in pi over 4, and I'm going to add in 3 pi over 4. And then we'll probably do 5 pi over 4 and 7 pi over 4 if we want to show 2 periods of this thing. 2 periods is not necessary. A was 1, so something going on at 1, something going on at negative 1. So now you start filling in your values. Well, what's tangent of 0? Tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent of pi over 2 doesn't exist, which means we've got an asymptote. Tangent of 3 pi over 4, well, now we're in quadrant 2. How does tangent turn out in quadrant 2? It turns out negative. What's tangent of 45 degrees? It would be 1. Put it in quadrant 2, it becomes negative 1. Tangent of pi is 0. Tangent of 5 pi over 4. Now we're in quadrant 3. Tangent of 3 pi over 2 is another asymptote. Tangent of 7 pi over 4, negative 1. Tangent of 2 pi. You want to know what this graph looks like? What it really looks like, it's a lot like an x cubed graph. Kind of like I've referred to it as a speed curve before. But one period takes place again here. That's one period of tangent, and it takes only half the time, half the x values for it to create one period. And therefore, when we look at this graph, this is actually 2 periods, and that's something that people get confused from time to time.